Good afternoon and good morning, everyone. My name is Jörgen Kvist, and I serve as the Director of Industry Practices and Procurement at the Canadian Construction Association. I'm pleased to be your moderator for today's session. The CCA represents more than 18,000 member firms through a network of 57 integrated local and provincial partner associations. With a truly national and cross-sectoral presence, we advocate for key industry priorities, including infrastructure investment, workforce development, innovation, and the promotion of the best practices in construction. Our greatest strength is in our members. Through our National Advisory Council, which represents civil trade and general contractors, manufacturers, suppliers, and local construction associations, we ensure that member voices share and shape our advocacy and programming. I also want to take the opportunity to promote the upcoming Best Practice in Construction Symposium in Toronto on October 30 to 31st, which is made by practitioners for practitioners. Now, let's get started. Please join me in welcoming our panel of experts. Elena Sporsheva, VDC BIM Team Lead Ledcor from Toronto. We have Bruce Vasarhelyi, Director of Operations at Kinetic, Vancouver, BC. We have Jacob Simpson, which is the VDC Manager at Turner Construction at Toronto. We have Corey Richter, President and CEO at Corex Construction, Saskatoon, Saskatchewan. I also want to mention that the following people have been very involved in the preparation of the webinar. Ali Tourabi, Vice President Operations at Ed Brunette. Jessica Sidhu, Product Manager, Kinetic Construction Ltd. Stuart Smith, Vice President and General Manager, Turner Construction Company. And Sarah Mustafa, VDC and BIM Manager at Ledcor. Thank you all for being here today. We're now moving into the core of our session, 3 insightful case studies that highlight real-world applications and lessons learned across different areas of the construction industry. Each presenter brings a unique perspective, and I encourage you to listen closely and consider how these experiences might inform your own work. Our first case study will be presented by Elena, who will talk and walk us through a project that tackles 3D laser scanning. Elena's work offers valuable insights into how to deal with clash detection. Elena, the floor is yours.
Thank you, Jörgen. Can you move to the slide? Thank you so much. Good afternoon, everyone. My name is Elena Sporsheva. I'm a team lead at Ledcor's Virtual Design Construction Division. Today, I'm excited to walk you through our BIM journey on ZB Blocks 2 and 3, an award-winning adaptive reuse project that blends heritage with innovation. ZB is Canada's first one-planet community spanning 34 acres across Ottawa and Gatineau. Our focus was on revitalizing 52,000 square feet of historic masonry building, preserving their character while integrating modern systems. We used PDC from 2018 to 2021 with a modest BIM budget of $15,000. Please note that the BIM budget does not include the cost of the laser scanning or the Ferrocene license, as these resources are shared across multiple projects. Our tools include Ferrocene, Revit, 3ds Max, and Sketchfab, supported by our internal Ledcor virtual construction team. Nowadays, there's a wide range of scanning technologies available, from compact handheld devices like iPhone Pro, which can generate point clouds instantly through apps, though with limited accuracy, to high-precision professional scanners like the Ferro system that we use. There's a picture on the left. And back in 2018, such variety didn't exist, so having these options today is a major advantage. When we go on site, we strategically place the Ferro scanner throughout the space to capture data. And like some photography, the Ferro scanner records the exact conditions of a building, producing a highly accurate 3D representation. This process typically takes from a couple of hours to a few days, depending on the complexity and the size of the site. This results in a point cloud, a digital 3D cloud of dots, where each dot represents a precise point in space. Together, these dots from a digital copy of the real-world environment. We use Ferrocene software to process the raw scans. This involves cleaning up the data, registering the scans, and validating them. Registration also can take a couple of days to ensure that all scans are aligned correctly. While devices like iPhones can produce point clouds instantly, they lack the precision required for many professional applications. The choice of scanner depends on the accuracy requirements and scope of the project. Once the scan is polished, it becomes our precise starting point, replacing outdated drawings or assumptions and enabling confident decision-making based on real-world conditions. End product scan is on the right picture. Next, we either build or receive a 3D model, for example, from our consultants. This model represents what's planned or designed. Now we combine the point cloud and the 3D model. In our case, we used the 3ds Max, but you could use our like any other modeling software. This step allows us to validate, does the real world match the design? Next, please. Finally, we upload the combined models to Sketchfab. Sketchfab is an online 3D viewer that let us share and interact with complex models directly in a web browser. This process allowed us to verify steel framing alignment with the existing heritage walls, floor level differences across the building, structural grid shifts or misalignments before construction began. And using Sketchfab gave the team an accessible visual way to validate accuracy, identify risks early, and communicate findings with all stakeholders. Point cloud usually shows up in the colors of real-world object or in just black and white. That depends on the scanner settings and capabilities. To make things clearer, we applied color coding in our models. Scanned facades appeared in pink, while modeled steel beams and columns were highlighted in yellow and gray. This straightforward method helped everyone from engineers to project managers quickly distinguish existing elements from new ones, streamlining project coordination. Instead of marking up flat drawings, we placed comments directly onto the 3D model. This enabled team members to focus on specific areas, review details from multiple angles, and collaboratively resolve issues in context, dramatically improving problem-solving speed. For example, in this case, the comment was to draw attention to the gap between building and a skylight that varied in different areas from 50 to 60 centimeters. Sequential overlay animations bridged the gap between 2D design and 3D models. We demonstrated current conditions, layered in 2D drawing details, and added modeled elements for a comprehensive view. These animations supported team reviews, illustrated system interactions, and made complex changes clear for non-technical stakeholders. The animation process shows first the 3D model with point cloud in its current state, then the 2D drawing details overlaid onto the model, and then modeled elements added to align with the drawing details. One of the most important lessons from this project was the creation of a digital twin. By combining the as-built scans with the design model, we ended up with accurate digital representation of the building exactly as it's supposed to be constructed. This became a single source of truth that the stakeholders can rely on. The key takeaway is that a digital twin extends beyond construction, making it a long-term asset throughout the building's lifecycle. Another lesson we learned was how useful it is to combine 2D drawings with the 3D model. On paper, complex details like how a facade connects to the structure or how a roof is built can be hard to understand and often depend on someone's experience. By overlaying these 2D drawings directly onto the 3D model, we gave everyone the same clear visual reference. This helped us see how different systems fit together, spot gaps or mismatches between shop drawings and the model, and catch issues before anything was fabricated or built. The key takeaway is that combining 2D and 3D isn't just helpful, it's essential for complex assemblies. It removes confusion and makes coordination much more reliable. This helped us check measurements directly in the 3D model and compare them with the grid system. That way, we could quickly spot if anything, like structural parts, facade details, or floor levels, was starting to shift out of place. It meant we didn't have to rely on manual checks or guesswork, and everyone had the same clear reference points. The big takeaway is that using both measurements and grid overlays make things more accurate and helps catch problems early. By using animations and cutaway views, we could show not just what the finished space would look like, but also how each system gets installed and at what order. This made it easier for the team and stakeholders to understand the process, something that regular drawings often can do. The 3D model also gave us a clear preview of materials and finishes, which helped reduce confusion and make sure everyone was on the same page before construction started. One important thing we learned was that often had to adjust shop drawings to match the real site conditions captured by the scan. This helped make sure everyone would fit properly during fabrication. The main takeaway is that using model-based visuals help connect design to real-world execution. It clears up confusion and makes coordination much smoother. To conclude, this project showed us that laser scanning and 3D point clouds are powerful tools that bring real value across the lifecycle of a building. They reduce errors by capturing existing conditions precisely, improve collaboration by overlaying scans with models, and make communication clearer with color coding, annotations, and animations. For small businesses, the recommendation is to start simple. Use scanning on the project where accuracy is critical. Bring the scans into a model and share that with your team and clients throughout easy-to-use platforms. Depending on your budget and precision needs, you can choose from a variety of laser scanning tools like a smartphone-based app like Sitescape or iPhones or iPads Pro. They offer a low-cost entry point for quick scans, or handheld devices provide a balance between mobility and accuracy, ideal for medium detail work. And then professional grade terrestrial laser scanning, they deliver a high precision and range, and they're suitable for complex or large scale environments. Over time, these tools can become part of your standard workflow, improving not just construction accuracy, but also long-term facility management. The key takeaway is that reality capture and 3D modeling aren't just advanced tools for big players. They're accessible, practical, and can give small businesses a competitive edge. Thank you, and back to you, Jürgen.
Thank you very much, Lena. That was a very thoughtful and informative presentation. It's always inspiring to see practical solutions in action. Next, we will hear from Bruce, who will share a case study focused on modeling existing conditions. Bruce's experience brings a different lens to today's discussion, and I'm sure you will find it equally compelling. The floor is yours, Bruce.
Thanks, Jürgen. And maybe starting with a special thank you to Jessica Sadhu for her support in putting this presentation together. She put a lot of work in on our end, so really appreciate that. Maybe next slide, please. So the UBC Bioenergy Research Demonstration Facility, which I'll only say once, BRDF going forward, was a project that was important to UBC. They have a existing district energy system, and they were looking to expand their capacity, which was really key to their green energy goals on campus. And so we started in pre-construction on this project with them in January 2019 and ultimately finished construction in May of 2022. Next slide, please. So from the outset, or maybe an overview of this project, in 2019 dollars, it was a $12.4 million project. I'm not sure what it is in today's dollars. I think there are some more zeros that would be added on. At a summary level, our costs for BIM were in the order of $40,000. And again, that was including the cost of scanning. And so following along with what Elena talked about, a large part of what we did here involved point cloud scanning, laser scanning. Our application was, the notion that we're going to be bringing all of this new equipment into an existing building and an existing operating industrial facility, and needing to understand that things would work and how would they fit. The software utilized, similar to what Elena talked about, we used Ferrocene. Using on the BIM side, we use CATIA, as well as Revit and Tekla, among others. And in this case, we used an external BIM consultant. Maybe next page, please. So for this project, we had an existing facility that was 16,000 square feet, roughly 100 by 160 by 45 feet high. It had an existing 6 megawatt boiler that currently operated, that had to continue to be operated throughout the heating season. We were going to be introducing a new 12 megawatt wood-fired boiler into that building. The building was mass timber construction with glulam beams and columns, CLT roof and wall diaphragm, no interior columns, so all exterior supported. And so among the challenges were that we could not, without major disruption, remove one of the existing perimeter columns or affect the existing structure, and yet we had these large components and pieces to go into the building. As well, we had a lot of large industrial equipment to be removed. And so, we had installation of large scale equipment. We spanned over the COVID-19, so that presented its own challenges for sourcing of materials. We had large equipment that was being fabricated throughout North America, Quebec, and into the US, conveyors, boilers, etc. Some of this equipment was extremely heavy, 100,000 pounds plus, if we had limited space to work within, and we were in an operating plant. And so our challenge here was to say, what do we need? This was very early stages, at least in my own BIM journey, as well as with Kinetic. And so we had a couple of pursuits, and we were on this project, we were operating in a silo, and we looked at not coming into the project understanding we would need BIM, but upon becoming familiar with the site and realizing that we have these existing conditions that we need to bring all of this equipment into. We have a problem that we need to solve, which is how do we ensure all of this equipment that's coming from all of these places are going to fit into this space. To that end, we then undertook to go out to outside vendors. We didn't have the BIM capacity internally at that time. I go out to outside vendors and ask them, can you do this? And if you can, what does it look like? Ultimately, we did retain an outside vendor. Next slide, please. And yes, these images as we go are from the project. So you'll notice in the background, we utilize the point cloud scan, and then by importing the Revit models that were manufacturer level models from the manufacturers of the various equipment, as well as the Tekla model from the structural contractors, we were then able to undertake clash detection and using both virtual models as well as animations, because as we were involved in this project, our ideas expanded. We went from, does this thing fit? Now that we're in this and not being BIM experts, being project manager, superintendent, project coordinator, now that we have this tool, can it do these other things for us as well? And so it was a bit of a journey of exploration of now that we have it, what more can it do for us? Next slide, please. And so I think that the turning point in this project, we talked early to the client about, we felt that modeling and scanning was going to be important to the project, and we wanted to see if we could introduce that into the project. It wasn't something that was factored into the plan or the budget. And at the time, the client understood that that sounded great, but it was going to be a hard sell getting support for additional funding for this. So we undertook this anyways ourselves. And this was one of the prime examples that we were able to bring forward, which showed there was a structural modification we needed to get the new equipment into the building. But that structural modification was going to leave behind the components you see on screen. And those we were able to show were going to clash with all of the boiler equipment that we were going to be bringing in. And so the very things that caused those structural elements to be needed in the first place and to be introduced. We're going to be in conflict with the boiler. We were able to indicate that in the model, then establish minor tweaks to make it work. This was something that, in a practical sense, 45 feet in the air, we would not have been able to visualize with enough precision, and it would have cost the project a lot of time and money as a result. And so with a couple of these examples, the client quickly learned that this was going to be a real benefit, and then came around to seeing the benefit and entertaining the idea of participating in the cost. And ultimately, we wound up splitting the costs 1/3, 1/3, 1/3 between ourselves, the major subcontractor, and the client. And again, quite cost effective. Next slide, please. Again, this is sort of a continuation of this same clash that we saw, and really what we benefited from was we were coming from the practical construction side, knowing what we wanted to see, not being expert in navigating models and those kind of things at that time. And so then being able to rely on an outside vendor in CAD makers who was able to sit down with us and do the navigation for us, and we could talk to them about what we wanted to see and what we wanted to evaluate, and they could undertake to drive the bus for us to look at these things. And so, being able to look from different angles and really understand how these pieces fit together was a great benefit to us. Next slide, please. We utilize this not only for clash detection and like those structural elements, because we had done widespread point cloud scanning of all of the existing facilities. We were also able to indicate at the outer perimeters of all this new equipment and at the edges of the newly demolished equipment, where in this case piping was going to be in conflict with new pipe rack elements, new piping elements. Again, really allowing us to evaluate how we were going to get this complex machine built inside of an existing facility that already had a complex machine that couldn't be interrupted. Next slide, please. Again, as we went along, our understanding and ideas expanded further, and we came to, after establishing that yes, we could make all of the equipment fit and we could evaluate the clash detection, the next question became we needed to get this equipment into the building, into the opening that we were putting in, but we also had to thread the needle with this equipment and get it in and around and over existing peripheral buildings, and then be able to get it through the building inside and skate it in and be able to elevate it. So beyond the clash detections internally, clash detections in terms of can we actually get it there in the first place? Now that we know it will fit inside, can we get it inside? And so the next question we asked our vendor was, could you animate that for us? And can we see, do we have the clearances? And so this, if I'm not mistaken, is this the video?
Yep.
Yeah, this is the video for it, and we could just show what that looks like. And so again, at a high level here, we're not showing the trucks and the cranes and whatnot. We're really utilizing the information that we've got for hoisting, and then zooming in to see, are we able to actually fit this equipment in, and what does that look like? Are we going to have multiple cranes and elevate it? But for the purpose of model, we removed the hoisting equipment and simply showed the boiler equipment itself. And in amongst this, in addition to point cloud scan and importing models from the manufacturers, we also utilized massing, which is what you see in the cube and the blue on the left, to represent the future hi-hat lab that we're going to be building inside of there. And so, yeah, as we went along, our understanding and exploration of what was going to be effective really grew. Next slide, please. Again, as we continued to understand, we looked at there was existing structure. We were able to scan and overlay drawings and models. And so drawings represented a door in the location you see highlighted in yellow. Scan shows where the true location of the door is. And the model is showing us where these new auger conveyors need to be. And it really allowed us to dive into how we're going to build this machine. Next slide, please. In addition, it really allowed us to coordinate within the various models that were coming forward between the conveyor suppliers and what their model looked like, and the structural steel contractor in this case, and find those clashes as well. And so again, we were just continuing to expand our understanding and use at that time. Next slide, please. So maybe lessons learned, and in summary, say from our perspective, be open to unanticipated benefits. And in our case, we came in, you know, as neophytes here. We knew we had an initial problem that we wanted to solve, but we were open to finding what else can we use this tool for now that we have it available to us. I think the other thing was, don't be intimidated by the technology. I think our approach was, we have a problem that we need to solve. We know what we would do in the analog world. And so is there a digital tool that can allow us to solve the same problem, not getting caught up in the jargon or the clicks of the mouse and those things. And then I think the other one was, be mindful of using technology, not using technology just for the sake of technology. So we're open-minded. We're finding creative ways. We want to use this tool, but not going down the rabbit hole of, well, now we have this fancy tool, so it would be just cool to illustrate everything. And so I would think those were three of our key takeaways. Next slide. And I think, you know, in summary and recommendations, I would say, don't be limited by your initial vision. And look broadly at how you can utilize the tool. And I guess, you know, lastly, just restating, don't be intimidated by the technology. If we view it as a tool and not something bigger than it is, we're able to then look at ways to utilize that tool. Thank you.
Thank you, Bruce, for those excellent insights, and for, you know, sharing the whole journey with us. And that video really took us on board. You know, to round out our case study segment, we'll now turn to Jacob, who will present the final case. Jacob's work addresses how to handle installation accuracy, and it's a great example of the many benefits of BIM. So over to you, Jacob.
Yep, thanks, Jürgen. You guys can hear me okay?
Yep.
Great. Okay, so if you can just go to the first slide, please, Jürgen. Thank you. So this example for this project, this is a downtown office tower, 40-year-old office tower. One of the challenges with this project was, when this building was constructed, the design intent was for this to be purely office space. There was cast in place concrete, and there was about 40 years of changes that had not been documented in this building. This was being renovated into a life sciences building for one of the universities in the GTA. And yeah, there was several areas of the project were also maintaining existing MEP systems which had to be factored in. There were as-built drawings for this project, most of which the team did quickly find out were not accurate enough to use for coordination. So if you could just skip to the next slide, please, Jürgen. So this project's value was around 22 million total. That's after all changes that occurred during the project. And we kicked this off in 2021. This was the first example where we actually tested out using augmented reality. And you can see the estimated cost for this, and the augmented reality platform that we used was Trimble. The beauty with augmented reality is there are essentially zero hardware costs with this technology. And I think most people who are on this call can probably admit to spending too much time on their phone and being pretty comfortable using their phones for the most part. 90% of the time that you would spend in this platform is actually in a smartphone and using an app. So one of the great things about this platform is it's very user-friendly and most people would be comfortable and it requires pretty minimal levels of learning and onboarding. And similar to Elena's presentation, this technology it provides similar end uses. However, I will say the caveat with this technology is you are not going to achieve that same level of precision with a scanner. This tool is really most helpful for getting an idea of the accuracy of the design with the actual conditions and highlighting issues that come up that are blatant there. So when a MEP system is clearly following a different path to what the team are predicting it will. If you could go to the next slide, please, Jürgen. Thank you. And you can just play this video just whilst I talk through this here. Thank you. So this is the approach and the process that's required from start to end to carry out this work here. This video on the side is just showing the end result of this process and how quick. It just really gives an example of how quick and easy it is to use. This was taken on an iPhone. This can also be taken on any tablets, iOS, Android, or the equivalent. So if you could just go to the next slide, Jürgen, and I'll just kind of kick off with the first stage. So this example here is showing the coordination that occurred between the ductwork and the structural ceiling grid system in one of the more congested areas of the project. This is just one of the examples of the coordination work that happened on this project. But for augmented realities, uses, it's really not limited to just MEP verification and validation. This can be used for architectural finishes, confirming door locations, casework is installed to the right areas, fixtures are set at the correct height, things like that. It really has a wide use of applications. But essentially, the first stage is to get your models to a stage where you believe that they are accurate to the conditions that they're going to be installed on site. And that will then take us to stage 2. So following the completion of coordination up until just before AR is going to take place, what you really want to do is to determine which areas are going to require most attention. So obviously those are going to be areas like mechanical rooms, electrical, sprinkler rooms, where you have typically a lot of congestion, a lot of complicated systems, and you don't have as much room for there to be deviations on site as say you would in just an office where you have a couple light fixtures and a diffuser, and if somebody's an inch or two off, it probably isn't going to be the end of the world. And you can see here that's kind of how this has been zoned out, this plan here of the project of one of the floor plates, really highlighting which zones have more congested areas and where we'd need to be spending more time and attention when we're using the platform. So that would take us to stage 3. So after that's happened, whatever systems or models are being used by either the design team or the trade partners, you can play this, please. Yeah, thank you, Jürgen. So this here is just showing the process of, and again, this is accessed through a web platform. There is no special software or high-powered machine that needs to be used for using this tool. And essentially, this video is showing all of the different systems of the project here are being loaded in. Each system would be identified with a color, whether that's an existing system or a new service that's being proposed. And that's preparing that model for use in an overlaid condition in the real world. And these systems can be trimmed down to certain rooms. If certain projects they're quite small and there's really only 1 or 2 locations where the tool is seen valuable, then these views can be trimmed to just a certain location, if that's a mechanical room or a pump room. then that's absolutely possible. And to be honest, the smaller the area of the model, the better it will run. The more model content you have, the more likely it is to have some lag and experience some issues. But most projects that won't happen. So after that has been combined, the last stage before this is going to be overlaid in the real world, and you can really see the differences on site, is to set up the markers inside the model. And that here will, yeah, thank you. You're going to just play that. Oh, sorry, I think it skipped ahead. Thanks. So this here is just showing the pretty quick process that that can be done to place a marker. So just a similar view to the previous, just a different tool on the web-based applications, selecting to place a marker. And when you place markers, you want to ensure that you're referencing locations that you know that you have a high confidence in their location. So things like concrete columns, walls, existing conditions that aren't going to change. That being said, you can really choose anything. It's essentially just something that isn't going to be moved anytime soon. So so you can see here, this is the process of setting up those markers. And then once that's been done, you'll get a QR marker like that, where you can enter information like room location, and you can add imagery to help people identify that on site. And that then takes us to the next stage. Thanks, Jürgen. So in the event that there, a lot of the time when we're working in these projects, there's a lot going on. People are moving material, stuff gets hit. And a lot of the time, if markers do get removed, where we've found value is to just create a quick one pager to show this is the marker number, this is the room, this is the location, and then the QR markers would all be printed off. This would be shared with your teams, and if they ever needed to replace those on site, they could just easily just refer to this one pager. See, it's a little bit hard to read in the image maybe, but most of these markers, they have a consistent height of 1.5 meters above floor level, because that tends to be a more comfortable elevation for people to just place that on a wall. And they're given round numbers. So like if they're 0.5 meter or 1 meter away from a wall, that's just an easy value for somebody to measure rather than a randomized one. Okay, next slide. Thanks, Jürgen. Okay, so this next video is taken on an iPhone. And you can see here when this starts, you start playing that. Thanks, Jürgen. So this is all taken on the Trimble Connect app. And once the app is, you navigate towards the combined view, whatever area you want to see, you can see here the model pretty instantly loads up on site on your phone. And this is a fairly dense model here. This has this is a civil service tunnel, so it has a lot of MEP content. So simply after you select place marker, you would just start, you would point your camera at that, you would move that around a few times. Depending on the levels of light, sometimes, it can take a few tries, but that pretty quickly loads up your model, and that will instantly align that to the real world there. And you can see to verify that, you can fade that in and out to get a quick sense of the alignment, and if there's anything that's glaringly obvious where stuff has been missed. In this case, we found that there were a lot of existing pipes that had been demolished that the designers didn't actually realize. So we were able to actually identify that pretty quickly. And then that would take us on to the next slide. So after taking those scans with a phone on site, identifying issues essentially is as easy as going over to the marker, scanning the QR, walking over to the area of whether that's door hardware, kitchen, cabinetry, or plumbing systems, pointing the camera to that, and then taking screenshots of the deviations. There are actually basic tools in this platform where you can take a quick dimension here or there. Again, it's not going to give the same level of precision as a laser scanner, but it will give people a pretty good picture if people are not following the design, or if the real existing conditions don't reflect what the designers have accounted for. In a lot of cases, when we've done this, we've found beams or floors or existing ceiling spaces have been lower or in completely different locations. And it's only after quickly checking that with this system that we can just send them a picture and let them know. and then more accurate dimensions can be taken on site if those are required. So then that just takes us on to the resolution stage here. So after those issues have been identified, whoever depending on the type of condition that was discovered and how easy that is to fix, if that's something that, if it's a structural issue that really can't change on site, then in most cases that would be updated in the models so they reflect the actual conditions. And then the systems could be adjusted to avoid those interferences. Or if it's instances where there's a slight deviation in a duct that's existing, then that would just be corrected in the model as well there. And then following that process of all areas, that would take to the validation stage, which would be to do another go round of the project after those corrections have been made. And if you play that there, Jürgen, that should just show quickly what you would expect to see with a decent aligned model. So again, it's not millimeter accuracy, but it paints a pretty good picture of the alignment between the model and the real world. And that takes us on to the lessons learned here. So there are a few lessons learned and recommendations that I would suggest. I'd say for a lot of projects, there's only one or two systems that really need to be checked, depending on their the criticality that they have. Keeping the model simple and avoiding over congesting that with certainly with detailed like pipe fittings and valves, a lot of the time, those are really going to slow things down, and especially structural designs. A lot of the time they'll have individual bolts, things like that. So those things can be pretty quickly filtered out. And as well, people being able to locate themselves on site and knowing that the marker that they're scanning is actually the marker that's in the model. So a lot of the time, just having an actual room name or a grid line, which you can kind of see in the image there, shows the grid lines. That really helps people to identify their location. Once they place that on site, they can pretty easily see that there's a grid line drawn on site, and that aligns with the model. That validates that they've scanned that properly. And yeah, I'd say the other caveat to this platform is there is a limited range to what can be viewed. So you can't scan a marker and view 20 meters away. You would have to have a marker located in your vicinity. And the reason for that is the markers are never going to be placed at the exact 0-degree angle on all X, Y, Z axis. So even if it's a 0.1 degree difference, if you look further away with this technology, the further you look away, the more that is going to deviate. And that is essentially just because of the marker placement can never be as accurate as the model placement. And then, yeah, thanks, Jürgen. So I'd say the best recommendations for this would be to just target small areas where challenges are expected. So heavy congested rooms, areas where there's bespoke designs, or there's if there's uncertain existing conditions or outdated shop drawings or as-built drawings, then those areas would definitely be worth checking. And I would say that it does help to bridge the gap between like a BIM coordinator team and a site team. The main benefit to this is that there's no hardware required for this. It's a very low cost license. It's a few $100, I believe, depending on where you're located for a year. That does not limit you to a specific project. Anyone can just sign into that and then access this into a specific project if they need, or in multiple projects. And yeah, unless anyone has any questions, I believe those are my main takeaways. Thank you.
Excellent. Very good and interesting presentation. I really like the breakdown of the steps. I think that's really helpful for the audience as well, just to conceptualize everything that needs to be done. I want to thank all the three presenters, Elena, Bruce, Jacob, for sharing your experiences and expertise. These case studies not only highlight the challenge we face, but also innovative ways of how the industry is responding. And we will now open up the floor for questions and discussions. And as we're waiting for that, I would like to ask Corey. Corey, that's been part of the group and in discussions and so forth. Anything that you see, Corey, that when you look at all these presentations, anything that kind of stands out or anything that you think will be good to share as a message as well?
I don't know if there's a message. I mean, the reason why we went down this path originally was, there's lots of smaller businesses that they just don't know where to start, right? That's always the daunting task that I've found, is that, you're a small to medium sized firm, and I mean, for a lot of the bigger companies, they have the budget and they have, IT professionals that are able to help to navigate this. But and maybe I'll turn this into a question. It'd probably be good if one of our panelists can answer it. If you're new to that side of the business, that as a company, okay, it's time we need to start adopting or figuring out how to participate. Where's the best place to start, right? If they need to take that leap, what's any recommendations on where the first step is to take?
Hello, Bruce. Yep.
Maybe as a sort of mid-sized contractor, yeah, I think we sort of happened into it. We had 2 or 3 things that were cropping up at similar times, right? I think we had a fire hall project that was trying to import a model and use it for clash detection. I believe we had a third project as well. I think my own recommendation would be, one of the easiest places to start could be a renovation project that involves a mechanical room where you could do a localized point cloud scan where you've got congested equipment and you need to do clash detection. I feel like if you're a smaller contractor doing renovation addition work, that could be an easy place to apply that. I think you could easily get sucked into wanting to scan everything and check everything, but I think the reality is where the congestion points are, and you could focus in on those things, and that could be a stepping off point.
Interesting. I don't know if anyone else want to say something there. Elena?
Yeah, I would say, to add up to this, like, to start with something user-friendly software that easy to learn and lighter, and then you can go into depth with something more advanced. But that also, again, start small with picking the project or a trade task like flash detection or quantity takeoff, let's say, instead of trying everything at once, as Bruce mentioned. Yeah, so and then I'll collaborate with partners, like maybe hire a third party that can do something for you.
Excellent. No, great questions and great answers. So I'm going to pick a question here. Let's see. This one I will ask Jacob to answer because he didn't do the first round here. Let's see. So this is more futuristic a little bit, with how BIM evolves. So how do you see BIM evolving in the next 5 to 10 years? Especially when the focus on AI and digital twins and things like that. What do you visualize?
And not to use the term everyone uses these days with AI, but I do expect there to be a lot of processes that used to require a week or 2 weeks taking a day, or taking, instead of a team of 3 coordinators, taking 1 coordinator. There's so many platforms and startups, even outside of the big players like Autodesk, who are actively working on ways to automate certain processes. So I'd say that would be the most drastic change that I would expect to see, is not only large organizations setting that up, but there are actively multiple startups who are working on different tools to automate certain processes, make data more accessible, and how to link certain platforms together that previously were not, that was not possible.
Interesting. No, that's it'll be interesting to follow and see what happens. I mean, I believe if you look at AI and how that developed, just in the last 2 to 3 years and how it skyrockets into all kinds of things we never thought about. So yeah, very, very interesting. So I have a question here about Trimble Connect. So Trimble Connect, are you in Pro Plan or Innovate Plan? That's very specific questions. I don't know if you can answer that one.
I would have to check. I believe it's Pro Plan, but I'd be happy to confirm that and
Perfect.
get back.
Excellent. Okay, let's see. We have time for a few more questions. Another question that just came in. Should BIM VDC be part of the corporate strategy? And should there be a separate department in the company for BIM VDC?
I would say yes.
I think
Bruce?
I'd say we come at it from a slightly different place in our lean journey, where we've looked to BIM VDC is, we find it as integral to lean, an integral piece, and then we've looked to roll that into our operations, so that team's part of our operations. Maybe we have the luxury because we're smaller and smaller projects as well, but so far we find that really works well for us, and I think we have, after initial dabbling, we did make a point of making it part of our business strategy and having support from senior management and looking at a planned implementation.
Interesting. So just for reference there, Bruce, so how would you define that as a strategic goal? Is it the usage of it, or is it like how do you follow, like how do you measure the implementation and involvement?
I think we started with creating a document internally as well, our BIM goals document, looking at not all projects are the same, and so what does an individual project need? And then as we've, so our strategy was to be open to and look at opportunities to include BIM and find ways for that to benefit our projects, and then leaving it open to evaluate what specific project needs are, and then look at the use cases on those things.
And I think on that note as well, just to follow up on that question, when you did that transition, Bruce, what were some of the challenges your organization faced when adopting BIM, and what did you do to overcome those potential challenges?
I think some of the challenges were, I think initially we didn't understand that it was integral to lean and really a lean component. And I think having, the right bums and seats was probably the biggest challenge. And once we had understood that, then we were really on good footing.
No, that's really helpful. Okay, let's see. I'm just going to pick up the next one here. I think we have time for one more question. And maybe for Elena, just from with BIM and collaboration, have you seen in your work that BIM changed the way teams collaborate across disciplines in a construction project? Did you see a difference in how people were working together using BIM?
Oh yeah, I feel like in every other project, depending on the complexity, we can see a drastic change and towards even like implementing BIMs, and the trades companies not only deliver the 2D drawings, but also deliver 3D models to us. And also the more the prefabricated use that we have. So let's say, as an example, something as a mass timber, everything is prefabricated and delivered on site, and everything needs to be coordinated beforehand. And just the way of the coordination, using the 3D in every single instance, like with such a precise detail, like with bolts and nuts. That saves us time on site, and it saves a lot of money fixing, again, some kind of like problems on site. So that's just a different workflow. It saves a lot of time, again, and effort that site team would put on site rather than using everything in BIM and plan early.
Interesting. Something that we hear a lot about is with steel and concrete now being from a sustainability standpoint integrated into scopes of RFPs and RFQs and things like that coming out, especially from the government. Do you see that, when it comes to BIM, how can BIM help with the sustainability piece? We've seen different ways of being able to have that data available when you calculate the life cycle management. But from the three panelists here, do you see anything that how can BIM help sustainability, calculations and construction?
Yeah, I can take this one. So basically with a BIM model, you can test it with like energy use or materials or carbon impact. There's a lot of parties and softwares that integrate with the 3D models that you can do it on the design stage. An operation stage, when we link the model with a digital twin, that BIM can help with like energy, maintenance needs, and equipment life. So owners run buildings more effectively. So yeah.
No, that's a great perspective. Jacob, do you have something that you wanted to add?
Yeah, sure. I think it kind of adds on to what Elena was saying. Like at the end of a project's life cycle, most large-scale projects will hand over the models either, as Elena referenced, digital twin, or 660 operations handover could be like another term. And that really is a replacement from the traditional paper-based operation manual binders, and all of that data is integrated into the model for mechanical equipment, electrical equipment, how much energy that requires, where the manuals are, what's the power, and all that data, the energy performance of windows, fire ratings, that sort of thing. So yeah, that having that information is certainly able to help assess how effective and well built the model and the designs are.
Perfect. Okay, I think we're at the end here. I just want to say, before we wrap up, I would like to extend a heartfelt thank you to our presenters for sharing their valuable insights and helping bring today's discussion to life with real-world context. Your contributions are truly appreciated. And to all of our participants, thank you for joining us. We hope this session has provided a clear understanding of unique challenges and opportunities involved in undertaking construction projects. If you have any follow-up question or would like to explore this topic further, please don't hesitate to reach out to myself or Canadian Construction Association. We're always here to support your work and continue the conversation. So again, thank you to everyone for their hard work preparing this, and I'm wishing you all a productive and enjoyable rest of your day. Thank you.